Welcome to Statics Lectures by Civil Thinking, and today we are going to understand the concept of method of joints. In this class we will see how to apply the method of joints to find the member forces in the trusses. Before I move on, I suggest to you to please watch the video lecture on analysis of trusses one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now let us go into our class. Now we will see how to apply the method of joints to find the member forces. Okay, now you know what are member forces. They are the forces in a truss. For example, this is a truss. Okay, now this has 1 2 3 4 and 5. Okay, this have 5 members, 1 2 3 4 and 5. Okay, these members we have to find the forces. Let us say this is F1, this is F2, and this is F3, and so on and so forth. We have to find these forces carried by these members, okay, with the help of method of joints. Okay, now let us read here. If forces in all the members are needed to find, then this method is the best. Now when you have to find all the forces, okay, in all the members, that is you have to find F1, F2, and here is F4, this is F5. You have to find all, okay, all member forces, then method of joints is best. If only force in a particular member or a few members is to be found, then we apply method of what? Method of sections. Okay, when we had to find forces only a few members, only one member or two or three, okay, then we apply method of sections. But if we have to find all the member forces in the truss, then we apply method of joints. Okay, so to find the forces in all the members, we have to follow some steps. Okay, so what are the steps? The step first one is draw the free body diagram. Okay, now suppose if we have some support here, okay, we have to convert this support in terms of it is forces. Okay, now we know this support have two forces like this and this. Okay, so that becomes the free body diagram. Now the step 2 is check the static indeterminacy of the truss. Now this step is not always important. Okay, this may not be important if you know if the truss is determinate. Okay, you know what is a determinate structure. A determinate structure is something in which we can find the unknowns with the help of only equations of equilibrium. In determinate structures we don't need more than equations of equilibrium. Okay, equations of equilibrium, we only need these equations. Okay, and what are the equations of equilibrium? It is this: summation f of x is 0, summation f of y is 0, and also summation of moment at any point is 0. These are the three equations of equilibrium. If a structure is determinate, we need only equations of equilibrium. And if a structure, if the truss is determinate, then we can apply the method of joints. If the truss is not determinate, okay, then we cannot apply method of joints and method of sections. Okay, both method of joints and method of sections, they can be applied only to the trusses if they are determinate. Okay, we can apply these two methods only to determinate trusses. Okay, now if in the problem it is provided that the truss is determinate, so you don't have to check this. Okay, but if you are not sure, you can check. Okay, now how do we find if a truss is determinate or indeterminate? Okay, for that we have this formula m plus r, okay, minus 2j. Okay, if it is less than or equal to 0, the truss is determinate. Okay, don't worry, we will see about this after a while. This is not really hard. Okay, so the point I want to make here is, if it is determinate, if the truss is determinate, you can apply method of joints. Okay, that's it. Now step 3 is what? First of all, you have to find the support reactions. Okay, always find the support reactions with the help of equations of equilibrium. Okay, equations of equilibrium are summation f of x is 0, summation f of y is 0, and summation of moment at any point is 0. Okay, now considering the whole truss as a single entity. Okay, now you have to consider this truss. Okay, suppose it is like this, you have to consider the whole truss as single thing. Okay, and you have to find support reactions. Okay, I will tell you in a little while what does it mean considering the whole truss as a single entity. Okay, it is not something big. Now when you find the support reactions, okay, suppose these are the supports. Okay, and we found the support reactions R1, okay, R2, R3, for example. These are the support reactions. When you find them, after finding the support reactions, you have to apply the step 4, which is apply the method of joints at each joint. Okay, at each joint one by one. Okay, now you have, for example, this is one joint, you have to apply the method of sections here. Okay, when we apply, for example, this is a joint. Okay, for example, this is a joint, this is a joint, and these are three members connected to it. Okay, now remember, when we apply the method of joints at this joint, it will give us all the forces in these members connected to this joint. Okay, so for example, we apply here method of joint is at this joint, so whatever these joints are, these members are connected to this joint, we will find the member forces when we apply joint method of joints here. Okay, so we found, when we apply here, we found in this member forces in these. Okay, because they are all connected to it. Okay, now what about this? So when you apply here, it will give you what member forces in these members also. Okay, now we don't have member forces in these two, so what we are going to do, since we need in these two, so this is the joint, we will apply here the method of joints, so it will give us the member forces in these two members. Okay, so one by one we apply method of joints in all the joints, or a given joints. It is not important to apply at all the joints. Okay, so we apply one by one and we keep getting the member forces. When we get all the member forces, so obviously we stop them, right? So don't worry, we will understand each and everything with an example problem. Okay, now remember, when you apply the method of joints, only these two equations you can apply. Okay, I am not saying these two equations are enough to find the support reactions. Okay, where is it? The support reaction. When you have to find the support reactions, you have to apply all these three equations. Okay, summation fx is 0, summation fy is 0, and summation moment is 0. But this is not method of joints. This is the support reactions, right? The method of joints basically begin from step 4. Okay, this is only the method of joints. Okay, this is method of joints. Now I included all the previous steps in the method of joints because they are important. Okay, they are very important. Then we can apply method of joints. Okay, because the method of joints basically fundamentally begin from here. Okay, and in the method of joints we have only these two equations. Okay, so we have talked a lot. Now let's understand method of joints practically. Okay, so let's move on to the example problem. Okay, here it is. Now it is said to find the member forces in the truss below. Okay, we have to find the member forces in all these members. Okay, remember, when you have to find member forces in all the members, we use method of joints. Okay, now by the way, it's already said to use method of joints. Okay, now, so what was the step 1? Step 1 was what? Draw the free body diagram. Okay, now this is a pin reaction, pin support, and in a pin support there are two reactions. Okay, vertical and horizontal. So let me erase this. Let us say this is AY. I am assuming upward axis as Y axis and horizontal axis as X axis. Okay, so at A, since here was a pin support, so it is, or a hinge support, so it is AY is one reaction and AX is another reaction. Okay, AY means reaction at A in the Y direction because Y is vertical. Okay, AX means reaction at A in the X direction because X is horizontal. Okay, now this is a roller support, and in a roller support we only have one reaction. Okay, so let us say this is dy. Okay, so this was the step one. Okay, we needed to find the draw the free body diagram, FBD. Okay, we did that. Okay, now what is the second step? Second step, now tell me, is this beam determinate or indeterminate? Okay, second step is check determinacy. Okay, since in the problem it is not said if it is determinate or not. Okay, by the way, it's already said to use method of joints, so obviously this has to be determinate, right? Now let's assume we don't know if it is determinate or indeterminate. Okay, so we have to apply this m plus r minus 2j. Okay, this is a 2D truss, and in a 2D truss this is the formula. M is the number of members. Okay, now 1, this is member 1, right? This is 2, this is 3, this is 4, and this is 5, right? Because this is a basically a square have four sides. These are four members, 1 2 3 and 4, and we have a diagonal member here, so that is 5. So m is 5. Now r is the number of external support reactions. Number of support reactions, here is 2, here is 1, so 2 plus 1 is 3, so r is 3. J is the total number of joints, A, B, C and D, right? These are all the joints. So 1 2 3 and 4, so this is 4, right? So now m plus r is 5 plus 3, right? Now 5 plus 3 is what? 5 6 7 8 minus 2j. 2j is 4, right? 2 4 is 8, so 8 minus 8 is how much? It is 0. Remember, when m plus r is less than or equal to 0, it is determinate. Okay, now we get the value to be 0, so this is determinate. Okay, we found it is determinate, right? What does it mean? It means we can apply method of joints. Okay, MOJ, method of joints. Okay, so let me erase this first, we will move on. Now we apply the second step. Now what is the third step? Third step is what? Find the support reactions, right? Support reactions. Now remember, it was said to consider the whole truss as a single entity. Okay, it means we don't have to care what is inside. If we have another member here or whatever, we don't care about these things. Okay, we consider the whole truss as one thing. Okay, so let us find the support reactions. Now we know we find support reactions since it is determinate, and in case of a determinate structure we find the support reactions with the help of equations of equilibrium. Okay, so let us apply equations of equilibrium are these: summation f of x is 0, okay, and summation f of y is 0, and summation of moment at any point is 0. Okay, so let us apply these one by one. Now summation f of x is 0, assuming forces to the right they are positive. Okay, this towards right the forces are positive, and towards left in the horizontal direction the forces are negative. Similarly, forces in the upward direction they are positive, and in the downward direction it is negative. Okay, we have to choose some sign convention. You can choose the otherwise too, but whatever the sign convention you choose, you have to stick to your sign convention from the beginning till the end. Okay, you don't have to change the sign convention in between the problem. So let's apply this. Summation of f of x is 0. Now summation f of x is 0 means sum of all the forces, f for forces in the x direction. X is horizontal direction, right? So now this 10 is towards right, so it is positive 10. right? Then we have ax, I'm assuming it towards right, so it is positive again. Is there any another force in the horizontal direction? No, all other forces are in vertical. There is no another forces. So we sum up all the forces. Okay, this is summation of forces, and we have to equate it to 0, right? So from here we get ax is negative 10 Newton, right? Because this was 10 Newton. Okay, now negative 10 means what? It means the value of ax is 10, but the direction is opposite. Okay, so here the ax was towards what? Right, but it is basically towards left. Okay, it is 10 Newton, right? That's what is the meaning of negative. When we have negative, we have to change the arrow, okay, to the opposite direction. Anyways, we found one support reaction. Now let us find, we have ay and dy, they are also support reactions. So this gave us one reaction, and we will apply these two, f summation fy equals 0 and summation moment at any point 0. Then we will find also ay and dy. Okay, so let me erase, or let me keep it here, no problem. Now let's apply summation f of y equals 0. Now assume upward forces are positive and it means downward forces are negative. Okay, now in the y direction we have 10, okay, they are downwards, so it is negative, minus 10 and minus 10, right? Minus 10 Newton and minus 10 Newton. What are other forces in the y direction or vertical direction? We have ay and dy, right? They are in upward, so they are positive, plus ay plus dy equals 0. Okay, so when we rearrange it, simplify it, so we get ay plus dy is minus 10 and minus 10 is minus 20, and when we throw minus 20 to the right side, we get plus 20 Newton. Okay, of course it is Newton. Now let's call this as equation 1. We had to find the value of ay and dy, but we don't get value of ay and dy. We get a relation between ay and dy. Okay, so we will apply another equation at any point. Summation of moment at any point is 0. Okay, now let me assume the point is what? Point is D. Okay, I am assuming the clockwise forces are positive and anti-clockwise will be negative. Okay, now let us find the moment at D due to all the forces. Okay, and then what? Then what we are going to do, we will find any of ay and dy. Okay, so a moment at D due to ay is going to be clockwise, right? So it is ay multiplied by, what is the normal distance between ay and point D? It is 5, right? This is 5. Okay, this is 5 meters as it is here. Ay multiplied by 5 meters. Okay, this we found the moment due to ay. Now 10 Newton is passing through D, right? The line of action of 10 Newton and is passing through D, so moment due to 10 Newton at D is 0, so we will not find due to this. Okay, now let's see about this 10 Newton. Okay, now this 10 Newton is going to exert an anti-clockwise moment at point D, right? So it is going to be negative, so I will write negative outside. 10 multiplied by, now what is the normal distance between 10 Newton force and point D? The normal distance is this, right? This is the normal distance, and it is again 5, right? I hope you understand. If you didn't understand anything or you had some doubts, you can comment, no problem, I will explain. Now we found moment due to this 10 also. Okay, now we have this 10 Newton, it is passing through D, right? The line of action of this is passing through D, so it is going to be 0, so we will not consider this one. Okay, now this 10 Newton, okay, is going to exert a clockwise, right? Clockwise movement at point D, so it is going to be positive. Force is 10 multiplied by distance between force and the point. The distance is this, right? The normal distance. Okay, it is 5 meters, right? So it is 5 we found also the moment due to this. Okay, now is there any another force? Is there any other force? No, we don't have another force in this truss. Okay, so all of it is 0. Okay, so let us simplify this. Okay, now this 5, 5 and 5, they will all cancel out. So what we are left with, ay minus 10 plus 10 is 0, right? So minus 10 and plus 10 is 0, so ay is 0. Okay, now we found the value of ay, right? So this ay is 0. So let me, if it is 0, so let us erase all of it. Okay, because it's 0, we don't have to show it with an arrow. Now since ay is 0, we will put ay here to be 0, right? So we'll erase this because it is 0. So we get dy is 20. Okay, so this dy is 20. Okay, so in this way we also found the support reactions. Okay, we have applied the step 3 support reactions and we found the support reactions. Okay, so let me erase all of this first, then we will apply step 4. Okay, okay, we applied the step 3. All right, now let's apply step 4. Okay, the step 4 is actually the what we have to apply the what method of joints at each joint, right? Each joint. Okay, and remember the rule, we will begin from the joint because we have 1, 2, 3 and 4 joints. So we will begin at a joint with some which is simple. Okay, so let us begin. Let me erase this first a bit. Okay, so let us begin with joint D. Okay, joint D. So this is joint D, right? And we have AD here. Of course here might be a force, so we will represent the force in AD with FAD. Okay, we assume the force is tensile. Okay, the tensile force is shown like this. If it is compressive force, it is shown towards the joint. Okay, now I'm assuming if it FAD is tensile, so if we get then a negative value, that means our assumption was wrong and it was actually compressive. Okay, so how many members are connected to point D? This is AD and this is FAD. Also this CD is also connected to D. Okay, so I will show the force in this CD member with the help of an arrow, tensile arrow. Okay, this is force in CD. Okay, these are all the members, okay, at this joint. So let's apply now. Now we also have a 20 Newton here. Remember, this is 20 Newton. Okay, now let's apply. Now I told you the equations of equilibrium in the method of joints are only two. Summation of f of x is 0 and summation of f of y is 0, right? So let's first apply summation of f of x equal to 0, then we apply summation of f of y equals 0. Now when you apply summation of f of x equal to 0 at this joint, now x is what? Horizontal, right? So summation of f of x is, now FAD is towards left. Okay, it is opposite to this because towards right is positive forces and towards left they are negative, so minus FAD. Okay, do we have any another force in the x direction? No, so this is 0. Okay, so we get force in AD to be 0, and when the force in a member is 0, we call it as 0 force member. Zero force member. Okay, and a zero force member is represented, it is either erased or it is represented with a 0 on it. Okay, it means this is a zero force member. Okay, now let's apply summation fy. Y means vertical Okay, so we know upward is positive and the downward is negative. So FCD is upward, FCD 20 is also upward plus 20. These are only forces in the vertical direction, right? So all of it is 0. So we get FCD is negative 20 Newton, right? We get a negative here. It means what? FCD, we have showed it, this is tensile, right? But our assumption is wrong. It is basically like this, okay? It is compressive, okay? So FCD, and when and we represent a compressive force with 20 C, okay? C means compressor. Wouldn't have to write negative here, okay? Because C means it is in compression, okay? So force in CD, this is CD, so we'll write here it is the force in it is how much? 20 C, okay? So we applied the method of joints here and we found the forces in these two, okay? All the members connected to this joint, okay? So but we also need in this, so we also need to apply method of joints at joint A, right? Because then only we can find the member forces in AB and AC, right? So let us apply the method of joints at the joint A, okay? So let me erase this first. Okay, now let's consider joint A, okay? Now joint A, okay, now we will not show this, right, because it is 0. We have also AD connected here, right, but we will not show this AD because this is a zero force member, okay? So we have AB here. We'll show the force in AB like this, FAB, force in the AB. We assume it to be tensile, okay? We always assume tensile forces. Then we have a 10 Newton at A towards left, right? What else we have? Now we have also this AC member. It is at some angle, okay? If I draw some dotted line here, then we have force in AC, right? It is like this, force in AC. It is inclined some angle theta, right? Now theta is what? This is 5 meters long, right? CD, and this is AD is also 5 meters. Since the lengths are equal, so theta is going to be tan inverse of, in this triangle ACD, right? In this triangle tan theta is CD divided by AD, right? So it is CD is 5 and AD is also 5. So it is tan inverse of 1, right? Tan inverse of 1, which is tan inverse of 1, when you use the calculator, the tan inverse value of tan inverse of 1 is 45 degrees, okay? So theta is 45 degrees, okay? So let me erase all of this. So this is 45 degrees, right? So we have here theta is 45 degrees, okay? Do we have any other member force at A? No, we have shown all the member forces at A, okay? Now let's apply any of the equation. Let us apply summation of f of x is 0, okay? Let us apply this equation. Now this is an inclined member, right? It is this FAC, this AC member, as you can see, it is neither in the horizontal and neither nor it is in vertical, right? It is in between, okay? And when we have a force or a member something like this, and we always have to resolve this into horizontal component and the vertical component, right? Now this FAC, let me show it a little big here. Let me enlarge it. Okay, now FAC, we have to resolve this force FAC into horizontal. This is FAC cos of theta, okay, because theta is angle with this axis, so this force is FAC cos theta, and this is FAC sine theta, okay. This is known as the resolution of forces. If you don't know the resolution of forces, don't worry, I have already made a video lecture on resolution of forces, you can watch it, okay. Anyways, we have resolved this inclined force, okay. Now we can safely apply these two equations. Remember this, whenever you have to apply any of these equations, summation f of x is 0 or summation f of y is 0, first of all we always have to resolve any inclined force, okay? Any force which is neither in x direction nor in y direction, we resolve them into the x component and the y component. Then after that we apply these two equations, okay? Now let's apply any of these two equations. Now summation f of x is 0. Now so FAC cos theta is towards right, so it is positive. FAC cos theta, okay? Then what other force is in x direction? It is 10, right? Now FAC sin theta is in y direction, right? Because this is y axis and this is x axis. Now in the x direction we are summing of forces in the x direction, so we have 10 Newton here. Towards left, so it is negative minus 10, right? Now do we have any another force in the x direction? No, okay? So this is all the summation, so we have to equate it to 0. And remember theta is what? Theta is 45 degrees, okay? So FAC becomes 10 divided by cos 45 degrees, okay? Now let me use a calculator to find the value. 10 divided by cos 45, okay, we get force in AC to be 14.14 Newton, okay? 14.14 Newton. Okay, so we found the force in AC to be 14.14. Since we get a positive value, it means it is in tension, because we have already assumed FAC to be tensile. Since we didn't get a negative value, so it means our assumption was what? Assumption was that the force is tensile. Since we get a positive value, it means our assumption is correct, and the assumption was tensile forces. It means it is 14.14 Newton tensile, okay? T for tensile, okay? So where is AC? This, the force here is 14.14 Newton tensile, okay? So we have applied summation f of x here and we got this value, right? We found the value of FAC. Now we have to find the value of FAB, okay? We have to find the value of FAB. So let me erase this first. Okay, now let's apply this equation. Summation of f of y equals to 0. So here FAB is towards upwards, right? So it is positive. FAB. Then we have FAC sin theta. It is also upwards, so it is positive. FAC sin theta, right? Do we have another force in the upward direction? I think no. These are all the forces in the y direction or vertical direction, so we have to equate it to 0, right? Now we already found the value of FAC, right? So we have to find the value of FAB. So from here FAB is going to be what? Negative FAC sine theta is 45 degrees, okay? Now FAC is 14.14, okay? So it is going to be negative 14.14 multiplied by sine of 45 degrees, right? So let me use a calculator to find the values. Negative 14.14 multiplied by sine of 45 degrees. So it is negative 10, okay? So all of it is negative 10 Newton, okay? FAB is negative 10. Now negative 10 means 10 but in compression, okay? So we found the force in AB member. This is the member AB. So what is the force here? It is 10 but it is in compression, right? C for compression, okay? So this way we found the forces in all these members when we apply the method of joints at this A, right? This was joint A. So we found all the member forces. How did we find these member forces? Because these members were connected to this joint. Since we apply method of joints at A, okay, and these were connected to this joint, that's why we were able to find these, okay? Now similarly, now look at this diagram. Now see, tell me, if I ask you the question, if I apply method of joints at point B, what we are going to get, right? So you see, BC and BA, these two are connected to this, okay, and we are applying method of joints at this point. Obviously we will find the forces in BC and BA, okay. So let us erase everything and then we will apply method of joints at point B, okay. We can also apply at C, but it doesn't matter. Now joint B, okay, when we apply at joint B, you see we already know here, right? BA we know it is 10. We need to find in BC, okay. BC is a horizontal direction, it is X direction, okay. So it means what, when we apply the method of joint this X equation, because we have to find only the forces, member force in the X direction. X means horizontal, right? We don't need to apply summation Fy equals 0 at B. Why? Because we already know the forces in the Y direction, right? AB is 10 Newton compression, right? It is in the Y direction. So why we will apply again summation f of y, right? So obviously we will apply summation of f of x at B only, okay? So let us draw the free body diagram of B, okay? So this is point B. Now let us assume this is force in BC, it is in tension, this is the assumption. Then we have at B, there is a 10 Newton force acting downwards, right? This, okay. Then we have AB, right? Now it is in compression. Compression means towards the joint, right? It is 10, okay. I don't have to write negative 10. If I draw it like this, away from joint, away from the joint means tension, then I needed to write minus 10 here, okay. But what I am going to do, I will draw the arrow towards the joint. Towards the joint means compression, okay. So it is 10 here. We don't have to write negative here, okay. Do we have any another member at point joint B? Okay, we draw all the forces and members of the joint B. So let us apply. Now we have to find force in the BC, okay. So let us apply this equation. Now FBC is towards right, root towards right is positive. FBC, do we have another force in the X direction? This is X direction and this is Y direction. Vertical is Y, X is horizontal, as you know. Now in X we only have this force, okay, so this is the summation of forces and we have to equate it to 0. So force in the BC is equal to 0. So BC is also what? It is a 0 force member, right? BC is also a 0 force member and we represent a 0 force member with the help of something O like, okay. This is 0, it means the force in this member is 0, okay. So here we found how many 0 force members are here. This was a 0 force member AD, right? Then we have BC, right? Let us see if we find more 0 force members. Okay, so we found the force in BC also, right? Now when you look at the diagram, you can see we found almost everywhere, but we only need to find what? No, we found everywhere, right? Because this is 20 compression, right? Do we need to find the member force in any other member? No, we found everything, okay. So this is how we apply the method of joints to find the member forces in all the members, okay. I hope you get the concept, okay. So if you have any doubts, please comment, I will explain, or I can make another video if you have any problem. So that's it for today. See you in the next class. Thank you.